Hi, welcome to Understanding Complex Exponentials, Lecture 5, Angle, Addition, and Subtraction Formulas, Part 1. In this lecture, we'll use what we've learned so far to derive an expression for sine of x plus y in terms of sine x, sine y, and cosine y. We'll also assign the derivation of an expression for cosine of x plus y as an exercise, and we'll give the answer to that exercise in the next lecture. In this section, we want to demonstrate the utility of complex exponentials. Formulas for sine of x plus or minus y and cosine x plus or minus y are useful in geometry, trigonometry, and physics and engineering, but they are complicated and hard to remember. So we're going to show how we can use complex exponentials to derive them from scratch. And we should note that alternatively, we could also derive them geometrically, but we won't do that here. Okay, so let's derive an expression for the sine of x plus y in terms of sines and cosines of x and y. We'll do this in 4 steps. First, we'll write the sine of x plus y in terms of the complex exponentials e to the I x plus y and e to the minus I x plus y. Second, we'll write e to the I x plus y as e to the ix, e to the iy, and we'll write e to the minus I x plus y as e to the minus ix, e to the minus iy. Third, we'll write e to the plus and minus ix in terms of sine of x and cosine of x, and we'll write e to the plus or minus iy in terms of sine y and cosine y. And fourth, we'll simplify our expression. Okay, let's get started. So, step 1. We'll start by rewriting sine of x plus y in terms of exponentials using sine theta equals e to the I theta minus e to the minus I theta over 2I. So this gives us that sine of x plus y is equal to e to the I x plus y minus e to the minus I x plus y, all divided by 2I. Okay, next, step 2. Now we rewrite the exponentials in terms of e to the plus and minus ix and e to the plus and minus iy. So from the previous slide, we had that the sine of x plus y was equal to e to the I x plus y minus e to the minus I x plus y over 2I. Now we rewrite each of those exponentials such that e to the I x plus y is equal to e to the ix, e to the iy, and e to the minus I x plus y is equal to e to the minus ix, e to the minus iy. Okay, now step 3. We're going to write those exponentials in terms of sine and cosine functions of x and y. Okay, so first of all, in the denominator, we have a 2i. We're going to pull a factor of 1 over 2i out front, just to make things simple. Next, in the numerator of our expression, we had e to the ix, e to the iy, minus e to the minus ix, e to the minus iy. We rewrite e to the ix as cosine x plus I sine x. We rewrite e to the iy as cosine y plus I sine y. We rewrite e to the minus ix as cosine of minus x plus I sine of minus x. and we rewrite e to the minus iy as cosine of minus y plus I sine of minus y. Okay, so we now have an expression for sine of x plus y in terms of sines and cosines of x and y. But it's complicated. Okay, so now we get to step 4. Simplify our expression. So we have our expression from the previous slide. And first, let's note that sine of minus x is equal to minus sine of x, and that cosine of minus x is equal to cosine of x. So our expression becomes the following. Sine of x plus y is equal to 1 over 2i times cosine x plus I sine x times cosine y plus I sine y minus cosine of x minus I sine x times cosine y minus I sine y. Okay, so we have our expression from the previous slide. Let's multiply out all of the terms. So this gives us a somewhat complicated expression. Sine of x plus y equals 1 over 2i times cosine of x cosine y plus I cosine x sine y plus I sine x cosine y minus sine x sine y minus the quantity cosine x cosine y minus I cosine x sine y minus I sine x cosine y minus sine x sine y. That's a bit of a mouthful. However, it simplifies down quite a lot. We can see that the two terms that go as cosine x cosine y cancel out. And also the two terms that go as sine x sine y also cancel out. Additionally, we have two equal terms that look like I cosine x sine y and two equal terms that look like I sine x cosine y. So when we cancel out the terms that cancel out and keep the remaining terms, we get that sine of x plus y is equal to 1 over 2i times 2i times cosine x sine y plus sine x cosine y. And those two factors of 2i will cancel. Okay, so we thus arrive at our expression. Sine of x plus y is equal to cosine x sine y plus sine x cosine y. Now we're going to leave as an exercise to derive the analogous relation for cosine of x plus y. So the answer is that cosine of x plus y is equal to cosine x cosine y minus sine x sine y. And we'll give you the hint that you can use very similar steps as we used here. We'll derive this expression in the next lecture.